Oh, totally. Okay. So I can start? Okay, welcome everybody to the, what is this, January 6th meeting of the SBAU, our second in-person meeting in Farrand Hall. At least a lot of us are here in person. And as we did last time, and I think we're going to continue to do, we're going to skip a lot of the business part of the meeting. For example, the financial report that Colin would normally give at this time, and we'll do that at our business meeting. So if you're interested in the stuff, we're not keeping things secret. Our information is open to every member. You can tune in or come to our business meeting, which will be the second Saturday of this month, and that is a week from tomorrow.
5 p.m.
5 p.m. Thank you.
By Zoom.
Yes, it's by Zoom. So we have, where's Pat? Where's the merch manager? If she would like to say a few words about our merchandise, we can cover that, and then we can cover the outreach. And then we'll get to our speaker for this evening. Yeah, I'm over here. I'll give it to you.
Are you do secretary? Are you going to do secretary? Or no?
No, this is recorded, so we don't have to take the secretary. We don't have to take notes on it.
Okay.
Is that what you mean by that?
No, just you want.
Oh, I was going to announce the position of secretary.
Yeah.
Yeah, I'll do that after
Okay.
you get through with it.
All right.
Thanks for reminding me.
Thank you, Jerry.
Okay.
Hello, everyone. My name is Pat McPartland. I'm the club's merchandise manager. I sell branded club items like mugs, patches, totes, blankets, short and long sleeve t-shirts, and a couple of different styles of sweatshirts. The prices and examples are on the club's website, SBAU.org, under store. I don't ship, but I will meet you where you would like to meet in the Goleta, Santa Barbara area, thinking like La Cumbre Plaza or Camino Real Marketplace, or here at the meetings. Send me an email at mgr@sbau.org with your order. And tonight I have a couple of mugs and hats, and I also brought a tote bag, which is pretty cool. It's a good size. Let me see if I have put this on the camera. And it's got our logo in color in the front. It's got a front pocket, and it's got a zippered area that you can go and put your favorite astronomy items into. And that's only $20. So all sorts of things to look at on the website. And back to you.
Okay, thank
Thank
you.
you.
If there's anything that you want to order and it's not there, or we're out of it, tell us and we'll order it. We'll keep you supplied. What Pat was referring to about the secretary is that Colin has been doing the secretary duties along with financial duties for the time of the COVID crisis and doing a good job. Thank you, Colin. And we have a new secretary, Tessa. What's her last name? Flanagan. Thank you. And she will be taking over as soon as we get the duties defined in more detail.
Well, she's ill right now, and she's going to be having surgery, and she's probably going to be months. So Pat and I
Yeah.
are doing secretary.
Oh, that's what you meant. Yeah. Okay. I don't like to discuss people's medical condition in public here, but anyway, we wish her a speedy recovery, and we're very thankful that Pat and Chuck will take over the duties of secretary. But we also, as an aide, instead of now writing down the minutes, we record these meetings so that we have that to fall back on. So just the highlights get written up and passed around and put in our archives. So with that having been said, we could now do the public outreach that we're doing.
Okay, for January, we have a bunch of schools lined up. To liven up in the wintertime here, which means that a lot of them are getting canceled because of clouds. So today, already the event on the 12th that we had scheduled, which was our first event at Providence School, has been canceled. They looked at the weather forecast and said, nope, we're going to come back in the fall. So then our next event is second Saturday. That's every month on the second Saturday. We have the free public star party here at the museum. We'll have the planning meeting before that on Zoom at 5 p.m. And then the star party is here at 7 p.m., 7 to 10 p.m. And then we have on the 18th, Wednesday the 18th, is Foothill School out in Goleta. That's set up at 5 p.m. for AU members. It lasts from 6 to 7:30. And we enter through a gate off of Cathedral Oaks that's kind of on the northwest side of their campus off of Cathedral Oaks, and we set up on their blacktop playground. Then on the 19th, we have Santa Barbara Junior High School. And so we'll have a talk inside the Marjorie Luke Theater. And then afterwards, we'll have telescopes set up out back behind the theater in their blacktop area. And we enter there through where two streets dead end kind of on the northwest side of their campus to get in. And I don't know the street names off the top of my head, but they are on the webpage and in the outreachy email. And that is starting at 6:30. So set up whenever you need to be ready to go by 6:30. Then third Friday of the month is the 20th, is Westmont, set up at 6 p.m. And for people who haven't been to Westmont in a while, they now have a gate on the first entrance off of Cold Spring. And at 7 p.m., the gatekeeper leaves. And so you'll have to come around and go through their main entrance and work your way down through campus to get to the observatory. It's between the baseball field and the athletic field. But for us, bringing telescopes and setting up, arrive at 6 and you won't have to worry about that. Then we have on the 24th, the fourth Tuesday of the month is where Telescope Tuesday is moving for 2023 because we got to keep up with the moon. And that is setting up and starting at 7 p.m. Then on the 26th, Thursday, we have an event at Dunn School up in Los Olivos. And they are offering dinner to any outreachees who volunteer and come up there. And the dinner is at 5:30, and then their star party is following that. And then it's not really outreach, but on the 30th, Mars will be occulted by the moon again. It goes from about 8:35 to about 9:23. So that'll be cool to look at. And as far as secretary, we've got everything from Colin, and we're kind of going through it. We're going to be sending out requests for people to update their information because we see a bunch of sort of outdated addresses from 3 years ago, and some people have moved, and we have about 170 people on the rolls, and it looks like a lot of them have expired even before COVID. So we're going to ask people to, not to say, hey, I still want to be a member, and update their information. So expect emails and mails coming about that. So thanks. We're also looking at, and this is something we're going to discuss at the planning meeting, is we used to have sort of 3 classes of membership. We had regular member, we had family membership, and we had an institutional membership. And that was mainly for Laguna Blanca School because their physics class would come here for extra credit, and also for UCSB students who would come for extra credit. And that was because we used to charge $2 admission for the star party. And that was a way for those students not to have to pay that to come and get extra credit. And since we've done away with that years ago, that we no longer charge admission to the star parties, we figure we can just simplify things and go back to a single level of membership. And then we got to decide if we're going to raise the price or not. So we're going to talk about that at the planning meeting. So anything else? No? Okay, we're good. Thank you. Thank you.
So we're going through an exercise, as he alluded to figure out what our recurring expenses are as the club. And then we'll match those with our projected membership and any dues we might need to charge. So if you want to be part of that, tune in for the business meeting a week from tomorrow night. And with that, we will now go to, I think I'm not leaving anything out. We'll go to the vice president, who will introduce our speaker.
Thank you, Jerry. We have a seat. Happy January 6th, everybody. It's going to be not only a day in infamy, but I think it's probably going to be another watershed milestone day like December 12th and 9/11. Hope not. Anyway, welcome aboard. We got some new people and I wanted to find out who you are. There may be more new people here today on our second meeting than normal folks. Where are the Art Harrises and the Edgar Ocampos and Martin and Janet Mazes? You're Nicole, right? And where are you from?
I'm in the valley.
Okay, and you are new?
I'm Bob, I just moved here from Denver.
How'd you hear about us?
Independent.
Oh, okay. Anybody else new? Raise your hand. Tell us about yourself behind that mask.
I'm Steve. I've lived in Santa Barbara about 30 years, but I recently retired. My family gave me a telescope. So
Could be could be. Who is?
That's Tim Crawford.
Oh, is that him with the glasses?
No, that's Tim Crawford. And he superposed his face on a picture of the sergeant in the Zorro movie. Oh, no.
Ah. Well, one of our longtime members is now back with us, and he's a good friend of mine sitting here in the front. I thought that was him, Mike Hardwick, who brought some pictures here. If you wanted, can we leave it up there? And anybody want to see them? They're stuff from your telescopes. You own about 4 or 5, don't you?
Yeah.
And they're kept at your son's house down in the valley, Thousand Oaks area. He's the first one to turn me on to the Christmas tree and asperism. I then learned about it from our Monday morning podcast, which we call the SBAU Astro Hour. I just wanted to run over a couple things. That program, incidentally, is 11 o'clock live. There was a gentleman that came in that said he watches that. That's you. Are you new or are you a member of the club?
well, I know I'm joining during COVID and I want to see like, okay, am I really still on there or not, or if I'm not, I want to make sure that I have enough members.
And your name, sir?
Neil.
And you live here in Santa Barbara? Fantastic. Anybody happen to see Celebrity Jeopardy last night on ABC? All right. I was watching and, well, hello. At the very end of Jeopardy, they have what's called Final Jeopardy. And the question, I knew it immediately, but the 3 people that, that's where you get all the marbles, didn't know it. The 2 women didn't even guess, and the guy guessed Stephen Hawking. And the question was, December 1999, Time magazine declared as the man of the century because he represented the embodiment of intellect. Who would that be? Exactly. XBB 15, get used to that phrase, that term. It's the new Omicron variant. Next month at the 3rd day of February, which is our next meeting, our 3rd, assuming it's live here, it'll be live with Dr. Joseph Bassi, friend of Tom Totten's, he turned me on to. He is a professor, I assume, of astronomy at San Angelo College in San Angelo, Texas. And he's going to do an incredible speech on space weather. So, without further ado, somebody, sometime back in early days of astronomy, spotted the floating rocks in the asteroid belt. And some we can see, some we can't, but someone noticed a star occasionally blinking out briefly. And it's when an asteroid passes in front of it. It's called occultation, which the asteroid occults the star. My friend who's going to tell you from the club, since our other incredible speaker that we were assigned to get fell through the cracks. But a lot of that happened over the holidays. So on behalf of the pandemic and the weather and people in the holidays, I apologize, but not for this show, because this is going to be as good as you've probably ever seen. Our man from Outreach to talk about occulting asteroids. Let's hear it for our Outreach coordinator, Chuck McPartland. Seen you somewhere before.
Yeah.
I'm not sure where.
Okay. Chrissy. Do I do a share screen here and we go? All right.
Yeah, let's get the lights
All
down.
right. Okay. Is there any, here we go. Is there any way I can minimize? Oh, I guess people at home aren't seeing the column on the right with the other people.
They can choose to see it or not see it.
Okay.
You can make it disregard your screen and it won't change what they see. You know how?
Yeah, you can't find my cursor.
Well, there you go. Yeah,
Okay.
you have it.
Up top, okay.
You see what
Ah.
it is. Yeah.
Well, I can just move it over. That'll work good. Oh, no, close enough. Okay, so
When you scroll over, you'll see a little thing
Okay.
you can.
click on that. Okay. All right, so some of you have suffered through this before a couple of years ago, but it's been a couple of years and there's been some developments. The last time I was talking about Gaia, the European Space Agency spacecraft that was going up and had made some very fine measurements. What they're doing is they're measuring the position and the brightness and some spectral characteristics of all kinds of like 2 billion objects in the Milky Way. And they are going to greatly increase the accuracy of predictions because they're getting finer orbits on asteroids and stellar positions. And so before, I used to do a lot of these asteroid occultations that were predicted to have a shadow path that passes across Santa Barbara. You know, you wouldn't think that's very something that happens very often, but there are billions of these things out there. Let's try to get rid of. Okay, can't get rid of that thing. But anyway, so there's the main asteroid belt there. There's billions of these things out there. We've cataloged over 600,000 last time I looked, just of the asteroids. And periodically these will pass in front of a star. And it used to be that I would have 30 chances a month, which, you know, you wouldn't think there'd be that many passing over Santa Barbara with shadow pass, basically eclipse passes coming over Santa Barbara. But there were, but a lot of them were really low probability and really huge error bars on the predictions. It used to be on the order of 100 kilometers. Now the error bars are down to 1 kilometer on most asteroid occultations. And so when I select ones to go for, I usually have a pretty good idea whether I'm going to get it or not. But, you know, in desperation, I still do some that aren't very probable. So this is the main asteroid belt here. This won't show, will it, on the Zoom? That's unfortunate. Okay, I do have a red laser pointer. I'm going to that little donut that we saw in the planetarium there that's out there between the orbit of Mars and Jupiter. And that's the main asteroid belt. And that's pretty much, most of them are in the plane of the solar system, but there are some that have high inclinations that have interacted with Jupiter and interacted with each other. And then there are the Trojans, which are those blobs you can see on either side of Jupiter. They're at the Lagrange points, and so those are stable orbits. And so those are the general asteroid type things. But then when we zoom out, now we have the Kuiper belt, which is also kind of disc-shaped out there. And that's trans-Neptunian objects. That's just the projector, I hope. Okay.
It's fine.
Fine on the Zoom. Okay. So then we have this other donut of stuff, trans-Neptunian objects, and there's billions of those babies. And we're starting to find more and more of those, although we haven't cataloged nearly as many as we have of asteroids. And then if you zoom out even farther, you can see how the Kuiper belt kind of blends out into the Oort cloud. And you'll see estimates on the Oort cloud radius of between 1 and 2 light years. So there's billions and billions and billions, to quote Carl Sagan, of icy things out there. And so these occultations are not only of asteroids, but of Kuiper belt objects and Oort cloud objects. And so it's getting information about stuff that's way the heck out there. And there was actually a high school professor, I think, in Japan, that set up a couple of Celestron 11-inch telescopes, automated, that were just staring at the sky, watching for stars blinking out, and he found a Kuiper belt object out there just that way, an unknown one. So it's a way of doing citizen science and finding new information that amateurs can do quite easily. So basically, the idea is you have an asteroid out there, and a lot of them look like ducks, as you can see from this one, and they are moving. Hello, they're moving. And so they can occasionally pass in front of a star and make the star wink out. And because the stars are essentially at infinite distance, they're essentially pinpoints unless they're close and they're really huge stars. So the light rays are parallel. And so when you map the shadow of the asteroid by doing these occultations with accurate GPS and timing information, you can actually map the shadow of the asteroid on the surface of the Earth and get its dimensions even more precisely than Hubble can do. And you can be stupid like I am and just go out there and videotape this stuff. So it's pretty cool citizen science. So the group that does this is called the International Occultation Timing Association, or IOTA. And they actually were formed way back in the late 50s, early 60s, and they were doing occultations by the moon, where the moon would pass in front of stars, like the moon is going to pass in front of Mars coming up. And they would actually go for grazes. They would go for the area where the limb of the moon, you know, where it was just barely occulting something, and watch the object, the star, wink on and off. And they would actually, that was how they were mapping the terrain around the edge of the moon. And because the moon wobbles, basically, from our point of view, you have lunar oscillations there. They mapped the limb of the moon previous to the some of the better mapping that we got once we had Apollo and other missions going there. But they also realized that they could do asteroids. And it wasn't until the 1970s that they pretty much, Dr. David Dunham got the idea that, hey, wait, maybe we can predict these things and maybe we can go observe them. And they started doing it. And so it doesn't take much of a setup. I just have a 5-inch scope. You do have some equipment. Where's my cursor? No, come back. Okay, so my cursor isn't showing. I got to show briefly there earlier. Anyway, so on the table there on the right, there's just the hand paddle that controls the telescope mount. Then there's another little whitish object on the end of a cable that controls the camera settings, although you don't need to have a remote like that. It helps because you don't want to be touching the scope and moving it around. And then there's a laptop that is capturing the video. And you can see kind of a muddled display there on the screen. That's the GPS display. On the left of the laptop is a video capture device that's feeding it in, and that black box is a video time inserter. So it's basically inserting its own video signal on top of the signal from the camera that shows, in this case, it's showing the GPS data, but you can also toggle it into a mode where it just puts the GPS time at the bottom of the image. And that's where you get this very accurate timing that lets you map the shadow of the asteroid on the surface of the Earth. And it's, you know, not a lot of equipment. It pretty much can fill up the back of your car, but not much more. You can actually bring a friend along, and you can go to remote sites. You can do this from a fixed observatory, but then you're really limiting the number of events that you can try to ones that happen to come right over you. But this way, you can drive as far as you want. And especially for some of these missions that occultations are supporting, I know Tom sent out the email, he kind of flipped it around saying that there are missions that are supporting occultations, but it's actually the other way around. The occultations are supporting some NASA missions in the past and in the future. And you find out cool things like this is an asteroid here, Cleopatra, that's kind of peanut shaped. And those lines are where people were observing and they saw the star wink out. And so you can see the black shape of the asteroid there. It's kind of peanut shaped. So you get surprises like that. You get asteroids that you find out that they're double when you thought it was only one, and one of them's a Pac-Man there. And there were a lot of people on this one, and the people who missed everything because they were in the middle. They get an award called the Pillars of Hercules Award, just to make up for the fact that they didn't see anything. And you find out some other interesting things. This is Cariclo, which is a centaur. Centaurs are objects that are kind of in between the Kuiper belt and the main belt and the Trojans. And these are asteroids that kind of hang out between Jupiter and Neptune. And they're usually named after centaurs, after half horse, half man types from Greek mythology. So this one's Chariklo, and basically they discovered it has a ring system. It has a double ring system going around it. And I'm going to try not to subject you to a lot of videos like I did before, but here is one taken by the European Southern Observatory showing how they found out that this thing has rings. So you'll see kind of the light curve at the bottom, and there's a star, the bright one kind of in the lower middle. Oops, and it kind of dimmed a little bit. And light was pretty steady. And then the main body of Chariklo went in front of it, it winked out. And then it came back. And then on the other side, it dipped again. So just from watching, you know, a simple blink like that, you can get all this information about things that are way the heck out there.
You're saying an asteroid had a ring?
Yes, a double ring system.
Was it
And they've found another one.
was it a dwarf planet?
No, it was a centaur, Chariklo.
Okay, but they're not as big as Vesta or.
No, no. Okay, so another mission that was supported was the New Horizons mission that went out to Pluto, and then they continued the mission and it went out into the Kuiper Belt and went past this object that they now call Aerokoth out in the Kuiper Belt. And so I actually participated in this one. They knew that Pluto was going to occult a star, and they had well, anyway, and so there was a campaign for people to go out and watch this Pluto occultation, and I participated in just a little 5-inch scope, and not only got more accurate positions for Pluto, but detected the atmosphere of Pluto because of the way the light curve changed. And then Aerokoth had been found by this, it was called something like 2013 MU69 or something at the time, but it's Kuiper Belt object that they had just found with Hubble, and they managed to redirect New Horizons to go to it after Pluto to continue the mission. And they saw that it was going to do some occulting of some stars. And they actually had huge campaigns down into Argentina and South Africa. It was all Southern Hemisphere stuff, where they actually got a bunch of 20-inch telescopes and cameras and trained a bunch of people, and they set up along, you know, across the paths and got a bunch of data, and they found out that Aerokoth had this double lobe shape. That was the first indication that it had that shape that it had. So here's my Pluto light curve, and because I didn't go directly, I wasn't a central chord, it's not symmetrical, but it shows effects of the atmosphere as it gradually dims down and then reached minimum brightness and then brightened back up again. So pretty neat for just a 5-inch scope sitting in the driveway. And then here's Aerokoth when they finally got New Horizons to fly by and take a picture. So the first hints they had that it was a bilobed object like this was because of occultations showing that shape. Okay. Another mission that IOTA people supported was this DART that just happened, the double asteroid redirection test, where they crashed a refrigerator-sized spacecraft into Dimorphos. So Didymos was the main asteroid, and Dimorphos was its moon. At first, it didn't have a name because they discovered it was double after they knew about Didymos. So at first, it was just called Didymoon. And a lot of people still say Didymos and Didymoon, but Dimorphos is the moon, and that's what they crashed into. And they wanted to see if they could alter its orbit, and they did. You know, you probably saw pictures of the smash up that happened, and they changed the orbit much more than they thought they could, way on the optimistic side. And it looks like it was a rubble pile, and that's what helped them actually divert it because of the recoil effect of all the debris that they blasted out of it. And so there were campaigns not only beforehand to get better astrometric positions of the two asteroids, but afterwards to see, you know, how the positions changed and how the orbit changed. And it's too dim and too small for me with my scope, but there was a guy, as far as California, there was a guy who set up down by Victorville with a 14-inch scope, and he actually got a chord on Dimorphos, on the little moon that had been whacked.
Did you say the name of that NASA mission?
DART.
DART.
Yeah, double asteroid redirection test. There it is, upper right. And so here's here's a graphic that they made before they knew what those asteroids actually looked like. They had a hint that Didymos had this sort of double cone shaped, and that's a hint that it's a rubble pile, because as it rotates, you get forces that basically drag things out on the equator like that and give it that bulgy shape in the middle. And that's similar to Ryugu and Bennu, which were the Hayabusa mission from Japan and the OSIRIS-REx mission from NASA that went and got samples from these asteroids. And it turns out that Dimorphos too, the little moon, it turned out to be a rubble pile.
Don't you remember the sizes of these things?
Okay, I think going from fuzzy memory that Didymos is about 1,500 feet across in diameter, and Dimorphos is about 500. So in that neighborhood. Okay, and another mission that's being supported is the Lucy mission, which is on the way, actually heading out there. And oh, and by the way, the OSIRIS-REx mission is going to come back in September and dump off its collection. It collected kilograms. They were expecting grams of stuff to come back, but they collected, it turns out, kilograms of stuff from this asteroid. So that's going to be dropping off its payload into, I think, Utah or Texas coming up in September. And there's this Lucy mission that has been launched, and its mission is to go out and visit those Jupiter Trojan asteroids that are in the Lagrange points on either side, 60 degrees on either side of Jupiter. One side is the Trojan War people, the other side is the Greeks who are fighting the Trojans, except there's a Trojan in the Greek camp and a Greek in the Trojan camp. So they're called the spy asteroids. I don't remember which ones are which, but so here's their graphic sort of. They're going to visit these asteroids because they think that these asteroids in these Lagrange points around Jupiter haven't been altered much, that they sort of date from the beginning of the solar system, and they've just been dragged along with Jupiter as Jupiter moved in and out. So they'll be largely unchanged and probably similar to Kuiper Belt objects. So they want to go take a look at these guys. Of course, they're way far out there, so they need really huge solar panels. And it's a multi-year mission. I think it's 2033 when they finish. So they're coming back to us actually after visiting the Lagrange point 4 Trojans and before they go out to the Lagrange point 5 Trojans. But they're visiting multiple ones, and they're even visiting an asteroid on the way as they're headed out there. And that's that little white dot on the left there in the path. It's called something like Donald Johanson. It's a small asteroid. And so several of these, hello. Okay, so here are the ones they're going to visit. Several of these have had occultation campaigns, and Patroclus and Menecius there, the two big ones in the upper left, are another binary asteroid system, both roughly similar in size. And there have been several occultations of those, and I participated in one campaign and got Patroclus. Menecius was to the south, and one of Jerry's friends got it in Texas, but he hasn't reported it. He hasn't reported his data. But anyway, Eurybates also has come across. I was going to try that one, but had bad weather. And then these others, Orus and Lucas and Polymele, are ones that haven't come by that I've had a chance at, but they're also as part of the campaign. And Donald Johanson there, you can see that's the little dinky one that they're going to visit on the way out. So here was the last Patroclus Menecius one in 2021 in May. And Patroclus was a path up at the top, and you can see that goes over Santa Barbara. Menecius was the one farther south that went across Texas. And all those lines are people that observed it and got hits on it, or didn't get hits if they're outside of the path. So there was a whole lot of people involved. And the more the merrier, the more data you get. And let's go back here. Okay, so I managed to get a positive on Patroclus. And I thought I had put in a graphic showing that, but apparently not. Oh, that was it. Okay, I thought I had one that showed something else, but here it is. Here was the dip. You know, you can see obviously when it passed in front of the star. All of this stuff is noisy. You got scintillation in the atmosphere. You probably a seagull going by over there on the left. But there's analysis programs that will pull this data out and tell you, the best fit for when the start of the occultation and the finish is, and everybody sends in this data and it gets collated and time shifted so that they can get the profile of the asteroid.
What is the y-axis number?
Those in this case are frame numbers. Oh, Y. Y is intensity and the X is the frame number of the video. Or the observation number. Well, my camera goes 0 to 255. It's just a 8-bit system. So some of the cameras have much more resolution on the brightness.
Can you clarify something to me? You
Yeah.
said those two biggest, that were pictured are binary, they orbit each other?
Yeah,
And is that what we're seeing here?
no, we're only Patricless.
With the two strips across the earth.
That was the two. One was Patricless and one was Menicius.
Oh, I see. Okay.
Yeah. But that was Menicius was too far south for me.
Got it.
And here's the path again, and it shows in red people who missed, who didn't see it. So you can see Patriclus was a little bit south. I was really lucky and close to the central line. So even though it was a little bit south, I still caught it. So some people, the green line is the central part of the shadow. And the blue lines are what they think the edges of the shadow are going to be. And the red lines are the 1 sigma error bars. And they usually tell you to observe anywhere within 2 sigma. And so you can see people are set up actually quite far away from the central path for a big asteroid with big uncertainties. In this case, not too uncertain for the size of it. But the reds are people that didn't see anything. And then the greens are people that saw stuff. So both of them were shifted slightly south. And lots of chords on it. And here was the result. So Patriclus at the top and Menicius at the bottom. So we didn't get full coverage on both of them because they shifted south a little bit, but good data.
Both eclipse the same star,
Yes,
so it's sort of like a parallax view of getting it here.
a little bit, yeah.
So is the green line on the top up there, number 8, is that your observation?
I am number 8, yes. And you can see the dotted line just above it, number 7, that's the predicted center line. So I was pretty close to the center line.
It would be great if you could repeat the question when you answer.
Okay, repeat the question. Am I the green line there at number 8? And yes, that was my observation. And 7 was the dotted line there. That's the predicted central path.
You're really close though, aren't you? I mean, 7 and 8.
Yes, yeah. Well, I was right close to the predicted center line. But as you can see, the actual center shifted a little bit south. So that gave give us a better orbit of Patriclus and Menicius, so that when Lucy gets there, they'll have a better idea. Might let them get closer to it because they don't have to now worry about positional uncertainty. And it didn't look like there was any other junk in there. Although with my timing resolution, I wouldn't have seen it, but other stuff that would have caused an occultation. So 2022, this last year, I picked out 129 potential, or 109 events potentially from my driveway or within driving range. And I managed to try 51 of them because of clouds or this or that or the other thing. 15 were non-observations. That's where I may have tried it, but I couldn't get a good enough cadence to get useful information out of it. The star was too dim, or the sky was too bad, and I didn't get good enough data. So that's a non-observation. 25 were negatives, 11 were positives, and 6 of those were multi-chord, which is where you get the really good information. It's sort of okay if just one person sees it, because that kind of helps a little bit with the astrometry, but you really get a lot more data the more people see it, because you get these multi-chords going across and you get the shape. And
You hit those occultations, the space between them. What does that tell you? Does that tell you speed,
The-
size,
the space between the,
when it starts and when it ends?
yeah, when it starts and when it ends gives you the size of the asteroid.
That's the size of the.
Yes, and that's a timing thing. They know about how fast it's moving in its orbit. And so you have to take, of course, different people across the US are seeing it at slightly different times. You have to kind of merge those all together and figure out what the shape.
It's already worked out.
No, the time is in the data that I take. Like, for example, on the video, there's time at the bottom inserted by that GPS time inserter. And then they have to say, okay, you know, somebody over here is going to see it a couple of seconds later as the shadow is moving across. So they have to kind of reconcile all. The times are very roughly the same. Most of these, the time interval over which the event happens over the entire Earth, you know, for a really, I mean, for a Kuiper belt object, that could be an hour. But for these main belt asteroids and things, it's a much shorter interval. And
that equates to size.
and the timing interval, yes, the timing interval equates to size. And you know, the bigger scope you have, the more of these you can do, the better time resolution you can get. With my kind of camera, it's a video camera. It's limited to the 30 frame per second, in which there are 2 fields, so you can extract maybe a little bit of extra timing out of that. It's actually better to do a full frame of 1/60th of a second, but that's enough to give you pretty accurate results out at those distances. There are new cameras that are not direct analog video because, okay, so this is a niche thing, right? And so equipment for this, you know, normal video cameras were used for a long time, and webcams and things like that. But if you want higher sensitivity now, you had to go to these security cameras that people have. And that's what I'm using as a modified security camera that's for low light. But they're adding all kinds of stuff to the newer ones that don't make them good for astronomy. They automatically do automatic gain control. So they're changing the sensitivity in real time to try to, you know, catch people who are skulking around in your backyard.
They have these astrophotography cameras.
Right.
We just bought the biggest one out there that we're using. And it's got a huge chip, and the data that comes off of it's
Right,
humongous.
right, so,
And they cool the darn thing.
right.
In order to keep the noise down.
Yeah, my camera's actually cool too, one of them, to keep the noise down. Yeah, so there are, Mike was saying that there are these big CCD cameras now with huge chips, and that's where everything's going to. The problem is you have to characterize very precisely the timing delays within the camera. Your readout times, when it actually took the image versus when you got the image, and all these other things to get the good timing. And you have that timestamp that's put on when that video signal gets to your inserter. So the cameras we've been using, these video cams, have been very precisely figured out over the years. But now with the newer video cameras having this other stuff that makes them bad for occultations, and also the video capture devices are being optimized for gamers video gamers who like to keep, you know, record of they blew up 5 aircraft and killed a bunch of orcs or something. And so those tend to drop frames because they want to go fast and get it, and it's not as critical to keep all the data that's coming. And so they drop stuff and they mess with it. And so it's no good for doing occultation. So people are going to these newer cameras that you mentioned, the CCD cameras that are used for imaging. And there are some CMOS cameras too. And you can use those even now, just a regular one, because you can, if you know the field of view, you can start recording your data as the star, and you don't even have to be guided. And you don't want to be actually for the CCD. You don't want to be guided. You let the star drift across the field of view, and you know the rate that the star is moving. And so you have to have some way of fixing what the time was at the start of your image and what the time was at the end of your image. And you look for the size of the gap. It's almost like taking a chord in this case, as it goes across your camera. And so you can then figure out the timing. Now there's a camera made by QHY that actually has a GPS receiver in it. And they will imprint GPS data on each frame that they give you. And they can do frame rates of 1,000 frames per second. So now suddenly your timing resolution is not 1/30th of a second anymore. The trouble is they're huge. And so it takes a long time to transfer the data over. But they do at least imprint a time on each frame. And at least with this system, I think it's the center of the interval that they looked at it. But you have to do all kinds of fancy calibration and everything on it. So it's a niche market. People are trying to get these manufacturers to make some cameras that are better for occultation. But, you know, I mean, what, 900 people in the whole world or whatever do this. And so it's not a market type thing. So it's changing. But there are ways you can still get away with doing this. If you don't have the video time inserters are meant for analog video. The CCDs, you don't have that, but there are people taking Arduinos and making little flashers that are attached to a GPS, and you hold that next to your aperture, and it flashes at the GPS 1 second interval. And somehow you get an idea of what the time is at the start of your exposure. And then you flash it again at the end, and you can tell if there's been some drop frames in there so that the data is no good, and you can figure out some of this. But it's making it much tougher to do some of this stuff. Okay. So here were two interesting ones from last year. This was Calliope back in March, and you can see it's pretty much coming over Santa Barbara, but in twilight. The lines on the left are showing you where it's daytime, and the brighter area on the right actually is where it's dark, right? And then there are dashed and dotted lines for the various civil twilight, nautical twilight, and astronomical twilight. So this was coming by in a fairly bright sky, but the star was magnitude 10. Of course, not naked eye, but you could pick that up with a telescope. If they're really dim, you sometimes have to set up the night before and get everything calibrated. And then you can do this thing where you don't need to be tracking, where you point it at a star that you can figure out is in the same part of the sky that your target star is going to be in, but at a certain interval ahead of that star. So you just let the rotation of the Earth bring that star in there. So you pre-point it the night before at a star that's at the same position where this event is going to happen for things like this in twilight, where you won't have time to set up in a line and get on target, and you can still catch it. So you don't even need to guiding or a bunch of other things. Some of these stars are naked eye visible. You can just crank your scope onto that and then wait until the event time to start your recording. So this was one where, again, we had multiple chords on it. You can see a lot of people in Arizona where they have nice skies. And it was pretty much, all the hits were within the shadow path, but it looks like all the people that set up were within the shadow path, and everybody who tried got it on this one because all the dots are green. And here it is. Okay, so it's another one of these oddly shaped asteroids. And where am I? I'm down near the bottom, number 13. Yeah, so I'm the bottom one. And unfortunately, there was a guy in Oklahoma who did number 12, and we were right on top of each other virtually. So we lost a little bit of data there. That's because the software that's used for coordinating these things was PC only, and I have a Mac. So I couldn't it was pretty hard for me to say, hey, look, I'm going to be observing at this position. But now, one of the new developments is there's cross-platform software out there that lets you both do the analysis yourself. It's in Python, and there is cloud-based, basically web-based software out now for going and getting these predictions. And you can say, hey, I'm going to observe this one, and I'm going to absolutely be there, or I'm not too sure, or whatever. And it will actually, up in the cloud, put your cord in there. So other people who are planning to observe the same event can see where you're going to be, and they can set up so that we don't stomp on each other like this. So that's pretty useful.
What's that short red line off the left?
Oh, that short red line, there's a red line on one side and a blue line on the other side. That's what they think the rotational axis is. This is an asteroid for which they have these ones that have models like this. You can see all these polygons in there. These are ones where the people who do asteroid light curves look at how the light varies just from sunlight on them, just how the reflectivity changes, and they can figure out the shapes. And they have various, hypothetical models, but then with this, with these occultations, you can now say, oh, this model fits much better. Tom?
So the asteroid is rotating, and people are looking at this across the United States. So the speed of rotation will really throw things off.
Does the speed of rotation throw things off? Yeah, across the US. Most of these don't orbit that fast, because if they were orbiting that fast, they'd be blown apart. Their structural strength wouldn't support it. So yeah, that's potentially a problem for the really small asteroids, but not so much for these big ones. But yeah, it's another thing. Another thing they take into account when they're doing the predictions and reducing the data is gravitational lensing from the sun and Jupiter. So they're getting down into, picosecond type effects that are happening on some of these. Okay, here's another one. This one's Andromache, and that was December 21st. So this is just a little while ago, the last time we had clear skies. And coming right over Santa Barbara, right over my driveway, perfect. So I set up for it. Pretty bright star, magnitude 11.9. Predicted max time 6.9 seconds, so a nice long event. I saw 6.2 seconds. You can see the asteroid's dimmer, magnitude 13.1. That's where the star actually winks out. Unless you're doing it, if you've got a big enough scope, you still see the asteroid also. So everything doesn't go away. In my case, everything did go away. But you can also have a case where the asteroid's brighter than the star, and you're looking at a really dim star. And there, what you see is a very small drop in the overall brightness of the whole system when the asteroid goes in front of the star. That wasn't
Chuck, we have a question. We have a question in the chat, Chuck. Obviously, this is going to the Zoom. That's why I'm echoing. Tim is asking, is most of these occultations used for the shape of asteroids? Is there useful info for NEOs?
Is there useful info for what?
Near Earth objects, NEOs.
Yes, some of the NEOs have been done, but they tend to be small and fast, so I can't do them with my scope. But yeah, there are people that are doing NEOs. I think it's called the ACROSS project, ACROSS. And when you go on this Occult Watcher cloud, you can get predictions for those events. I tend not to because I can't get them because they're small and fast. But sometimes if the star is bright enough, there might be enough data there. Tom.
So what about the range of electromagnetic wavelengths that people have used for occultation? What's the highest range of wavelengths used for the?
Yeah, I'm just doing optical, so just visual wavelengths. There are people who have done infrared, and I know they've done radio and radar. So mostly longer wavelengths, I guess. Okay, so here was the Andromache event, and what was interesting about this one is there's a lot of structure in the drop there. You can see where it's climbing back up. And this one is still being analyzed, so the results aren't up on the web yet, but there were at least 2 other observers that I know of that got this event. Some of them were on the edge of the asteroid, so they only had 2 and 4 second occultations. I was apparently closer to the center and got 6.2 seconds. And everybody is seeing structure in the rise back up after the occultation. And so that's interesting. That's why it's taking a long time for people to do the analysis. And it could be, what people are thinking is that it's an undiscovered double star, that the star that was occulted is actually a very, very close double. And so the asteroid only occulted, well, it occulted both of them at one point way down there at the bottom, but you can see other bits there where the other star was uncovered before the main one. They don't think it's anything weird about the asteroid. It seems right now people seem to be thinking it's just that there's something happening with the stars. And
you read 6.2 seconds on that.
well, okay. How do you read 6.2 seconds on the graph? That's the GPS time at the bottom there, but of course it's very crude notches. The analysis program, gives you a summary, and it tells you the error bars, and it tells you the start and stop time. And then when you feed it into the report form looks at the kind of camera you have, and there's a database of what the delays are in the camera, and it applies the final. The duration is still the same, but the start and stop kind of wiggle around based on that. Now, one of the things I wanted to do with this one, because there was structure in it, this is the report I sent in before I heard that other things were happening. And today I thought, well, you know what, maybe it'd be nice to stretch this out and get better resolution on the drop, and show some more of the structure. So I went and fired up the occultation analysis program, and it said, hey, there's a new version available, upgrade. So like an idiot, I said, yeah, give me the latest version. And now none of it works. So hopefully I sent in an error report. Hopefully that gets fixed.
So is the units on the left?
The units on the left are some arbitrary brightness thing. I only have a range of 255. So they've obviously concocted some other value here for the relative brightness.
It's not significant either, right? Predict, right?
We're looking for the time, yeah, is the main thing. Now, for some of them, you know, like the asteroid of Pluto, then you want to have a more precise value. But for this, it doesn't matter. So yeah, I'm not sure exactly what those units are on the left.
You kind of lost me on the blue dots. Are those people?
No, the blue dots are individual frames. Well, okay. So the camera is doing 30 frames per second. That's like the base video rate. But this camera is a modified surveillance camera for astronomy. So you can tell it to take 2, 4, 6, 8, 16, 32, 64, 128, or 256 frames and add them together. So it lets you see dimmer things. So it'll integrate. So it's like taking a longer exposure, even though it still is displaying things at the 1/30th second rate. So this is where you've put your data in, but you said, okay, I was integrating. So actually, you know, you'll see two values that are the same here, merge them. And I think that's why we get these numbers more than 250 here, because each frame may be slightly different based on the noise of the camera when you actually read that out. So there's other jitter that gets added on. They're not two frames that are exactly identical.
So that's noise.
So that's noise. And each one of those dots is an integration, which may have been 1/30th of a second. In this case, I think I was on 2 or 4 frame integration.
Just you.
Just me, but each one of those is a measurement that was made of the brightness of the star. So you can see the atmosphere is just wiggling things all over the place.
And the significant thing there is the space between the noise.
Yes, the drop.
Then you know you've got an occultation.
Right. If you see this big drop here, and there's also a statistical analysis that goes on as part of this analysis program that says, hey, you know, this drop wasn't deep enough or long enough for me to say whether it was just noise happening. So there is a little bit of, you know, sanity checking.
Because you have some noise down at the bottom. The blue dots that are.
Well, the lowest blue dot is down around between 200 and 220 there. That's outside of the occultation. Yeah.
We've got another question in the chat, which is, can you detect an asteroid passing in front of an extended deep sky object?
Well, the
Like a galaxy.
a extended deep sky object, no, just because especially not with my scope.
Jack, can you repeat the question, please?
Yeah, can you detect an occultation of an extended deep sky object or an extended object? So in this case, let's say across a planet or something like that. No, not really. Not with my stuff, and I don't think anybody's trying to do that. You know, an asteroid passing in front of Mars wouldn't give you much information on either, really. If you had enough information to predict it and you were able to see it, then it means they've got probably good radar data and everything on it too. So
I believe you told me earlier, most of the stars are not seeable by the naked eye, so you need the telescope.
right, most of these stars that you're doing the occultations on are too dim to see naked eye. Just because there's a lot more of those. It's a power law. You know, if you're 1/10 the brightness, there's 10 times more of you out there.
Well, if they ever announce that Vega or Betelgeuse or part of
There is an occultation coming up of Sirius, and there's an occultation of Betelgeuse sometime in the future that people have predicted, and those are ones that you could see naked eye, but you couldn't do very accurate timing on it. You just basically see it and go, oh, cool. But there was, I think it was 2017. There was a prediction that Regulus, so the bright star in Leo, the lion, was going to be occulted. It was going to pass over New York. So it was like huge numbers of people. So there was a big campaign. They got out software apps for cell phones. Because it was a naked eye visible star, you could hold up a cell phone. And they asked people to do an NNTP timing sync of their cell phone before they did it and afterwards, hold it up and get a video and send it in. And of course, it was cloudy over the entire route where things happen. So, but that was the most recent, naked eye visible star that was going to happen. Yes. It's just like, it would still be a band across the earth, the question was, because it's just like a solar eclipse, but with a different sun, different star. So the new developments across platform analysis programs are in Python, so everything starts with PY. PyMovie, which takes your video and extracts that light curve. And then Peyote, occultation timing evaluation, actually goes and extracts the time when it thinks things have happened and does the statistical analysis on the noise and things like that. And now there's this Occult Watcher cloud, which you can see at that URL at cloud.occultwatcher.net. And you can go there and see the predicted events that are coming. And, you can overwhelm yourself because there's basically thousands of things that come up. The problem is with the cloud version, they have not yet given you a way to say, I only want things that pass within 100 miles of Santa Barbara. So when you go and you say, hey, North America, so you have to winnow through that, but it does show you a globe of the earth and where the shadow path is. And so you can kind of eyeball whether it's going to go near you. And if you think it's going to, then you can click on that and get more refined data for the position. And finally, you can get it to come up in Google Maps and you can actually see, oh, it's going to pass right over my driveway or my neighbor's house. So it's pretty useful. So that's it for this year.
Question?
Yeah, question? Yeah.
I missed it, but, how do you know which star to like focus on and look at? Is it kind of arbitrary, or is there anything within the path that is going to happen? Like, how are you deciding what to focus on to look for that?
Okay, the question was, how do we decide, how does one decide which star to look at to see where this occultation is going to happen? The occultation is basically predicted for a star, one star that it's going to pass in front of. And then that's how they determine the shadow path, by looking at the relative positions of the Earth and that star. And so a lot of them are for dimmer stars because there are more dimmer stars. And so as far as I go for picking it, it's like, okay, the shadow path has to come across me. And then I look and say, okay, is the star too dim for me to get useful data with my telescope? Or is the occultation predicted time too short for me to get useful data for the timing and the brightness? And there's still, 30 a month that are possible. Chrissy.
Another question from the chat from Tim. He says, these are asteroids. Can you do comets? Then he says, oh, shoot, no way. They're too bright. Sorry. I started asking the question. Oh,
No. Okay, so well, you probably all heard that question. Can you do comets? Yes. And there are just people that did Schwarzman-Wachmann 1 and another one. So yeah, there have been occultations by comets. A lot of people expect, oh, you're going to see this gradual dimming. How can you tell if you've gone across the main body of the comet or if you're just in the coma and this and that? And it turns out the amount of debris coming off, even though the coma looks quite bright, is very little stuff. And so you only get a major occultation that you can detect if the actual body passes in front of the star. And so they got a size of like 6 kilometers on, I think it was Schwarzman-Wachmann 1. And there've been very few of those, because the big problem with comets is not so much that they're bright, but that they are active bodies. They are spewing stuff out. And so their orbit is changing slightly. They've got like rockets going off all the time on them. And so it's harder to get an accurate prediction on it. Okay. Oh, Dora.
Comment and 2-part question. So wonderful to be back.
Yeah, it's wonderful to be back. Yes.
And I missed a long time before. So lovely. This reminds me so much of the my epic eclipse adventure in 2016. Similar. And I guess the path of totality of a solar eclipse is 80 to 100 miles. So the first part of the question is, what is the path of totality for these things? And is either Vega or Sirius occultation going to be visible from Santa Barbara? Okay, so the question was, what is the path width of these things relative to things like a solar eclipse? And also, are there any naked eye stars that are going to have an occultation passing over Santa Barbara? So for the first part, you've got a big thing that's blocking the sun. That's the moon. So it's quite a wide occultation path, but
because the sun is so close to us, it has an angular size. So you get both an umbra and a penumbra. So it's unlike the asteroid occultations in that the actual umbral part is quite a bit smaller than the moon. So you get these 80-mile or 100-mile wide paths. Yeah, of totality. For an asteroid, the star is basically at infinity. The light lines are parallel. So the size of the shadow path where you get a total occultation, and pretty much they're all total, is the size of the asteroid. So smaller asteroids are narrower paths, and bigger asteroids are bigger paths.
Give me an example of what distance we're talking about. So
Right.
that's what you got.
Right. So this one is, what's the diameter on this baby? It's 100 kilometers. Okay, so 60-mile wide path there that you're seeing going across. Yeah.
That's not the size of the asteroid.
Yes.
100 kilometers across?
Yeah.
50 miles? And that's all from your graph.
Oh, upper right, it says the asteroid is in Dammit, which is which is one of the databases that shows those predicted shapes that they've gotten from light curves.
100 plus of this.
Yeah, 100 plus or minus 6 kilometers, 61 milliarc seconds at its distance. So
And they can see these things in northern Canada and way up in the Arctic Circle?
no, in this case, only along that line that you see.
Well, I know, but is there any reason it wouldn't hit the poles?
Other asteroids and other
Yeah,
stars.
yeah.
Oh no, they all over the place. Yeah.
They probably have to look at just above the horizon.
No, not necessarily. Straight up, they can. Okay, so the question was, can these be seen all over the Earth, like at the North and South poles and Antarctica? And yes, it just depends on the geometry between the asteroid and us. Of course, most of them are in the ecliptic, kind of. So that would kind of limit the visibility for really high latitude or low latitude places, or minus negative latitude. So near the poles, it's tougher. You'd be looking more toward the horizon, like you said. But you still have Kuiper belt objects and asteroids that are in high inclination orbits that can happen just about anywhere.
You said Pluto occulted somebody.
Yeah, Pluto occulted a star back
Yeah.
a couple of years
See
ago.
it?
Yes, yeah, that's where I got the atmosphere. Yeah, Pluto occulted and I got the atmosphere effects. And I think that was actually during one of our Bakara outreaches out there that I did that, because I remember a guy came up who was one of the people staying at the Bakara. We were doing our public observation there. And he said, "What are you doing?" And I said, "Oh, I'm setting up for an occultation." He says, "Oh, what is it?" And I said, "Pluto." And he said, "Oh, well, I was on an expedition to do a Pluto occultation 5 years ago that went across Australia." So it was one of those small world type things.
But at one time, for many years, our ninth planet was out in the Kuiper belt, wasn't it? Wonder if the people knew that. Isn't it
Well,
under the Kuiper?
Yeah. But they didn't know there was a Kuiper belt then.
Oh, they didn't.
Yeah, so the question was in the 30s, Pluto, was it in the Kuiper belt? Well, yeah, but we didn't even know there was a Kuiper belt then,
So that make it hard to find it.
Oh, yeah. Well, the farther away it is, the dimmer it is. So does that make it harder to find? Yes. But Pluto is big enough that people had an orbit for it.
Can you see its moon in your telescope?
In my telescope, can I see it's got 5 moons. Can I see any of them? Not visually, but maybe,
I've never seen.
yeah.
Charon or Charon?
Charon, yeah. If you knew there was going to be an occultation of the moon Charon by Pluto, that might be detectable.
Wow.
Because of its orbit, Yes, another
question from the chat. I've seen you do a few of these, Chuck, but many are in the middle of the night. Is your sleep affected because they're any different time?
Well, I'm up at all hours doing these. Some of them are 2, 3 in the morning. And that leads to some adventures because, a couple of months ago, I was I was setting up at about 1:10, 1:15, and at about 1:45, I heard a big ruckus from the neighbor's house. And he has chickens. He has a coop and he has chickens. And there was a big ruckus. And I was thinking, oh, the chickens are having a bad night. And I was doing something, sitting at a table, and I got up to go to my scope, and in the middle of the street was a bear, a great big black healthy looking bear walking up the street. Yeah, this is in Santa Barbara near Old San Marcos Road. And apparently what had happened was he raided the neighbor's house and killed and ate all his chickens and ripped his coop apart. And my first thought was, well, you don't belong here. Get out of here. So I said, shoo, shoo, shoo. And he took a step toward me and I started to think, yeah, you know, maybe that wasn't such a bright idea. But then he turned around and he went across the street into the neighbor's yard and figured out, oh, there's no way to get away there because he has a fence. So he came back out to the sidewalk on the other side of the street, and then he just continued on up the sidewalk. And then a couple of days later, I think that was the bear that was killed at Fairview on the freeway. Because he had been raiding chicken coops all along the Goleta foothills. Yeah, and what was really a bummer was I saw on the CHP page that, oh, this bear had been killed. I was thinking, oh God, you know, it's probably the same one. And they said, you know, the car hit the bear and the bear ran off into the gully. CHP officer went and he looked and he found the bear was dead in the gully. So they said, notified the Chumash to come pick it up. Because apparently there's some agreement. They didn't just call Fish and Game or whatever, animal control, that if it's a bear or maybe some kind of, you know, spiritually significant animal of some kind to the Chumash, that they come and get it. And so I thought, okay, well, that's good. The bear's not going to waste. But then a couple of days later, I read on InHat where a guy said, hey, I was out with my metal detector in his gully and I found a dead bear. So I don't know what happened, but apparently they didn't come pick it up. So yeah, they're, you know, all hours. But yeah, I'm retired. I don't care when I sleep.
Most of the astronomers are.
Yeah. We're night people. Yeah.
Yeah. Well, you did good.
Okay. Okay.
Gotta
Turn
tell
it
you.
back to you.
Just as, let me just close things out on my end here.
As I
Can't get through there.
pull out the connection.
I'd go around this side.
Yeah.
Doesn't get any better than that, I've got to tell you, even with our supposed pros, he's a pro. Pat, would you give him one of our priceless SBAU mugs? I think he has waived the $100 honorarium, but in a month, February 3rd, we'd like to grow. Tell your friends, bring them in, treat them to a night. We're going to talk about, I guess, the new fees. And I'm going to bring up at the meeting, if you'll put me on the agenda, Mr. President, a possible change in what we pay our people, because we got this new virtual thing to think about. At the business meeting, yeah, I meant to say that. Carol Ann Moore was up there. She was our longtime, and Tim Crawford is it? Tim's up there. Oh, was that Marty?
Martin's dressed like that, historical thing, yeah.
They okay, Martin and Janet? God, I miss her deviled eggs. They were so good. We'll see you on the 3rd, and it'll be Professor Bassey, your friend, talking about space weather next February. Thank you.
Good job, Chuck. And where do you get these wonderful speakers, Vice President? So anyway, I think that you talked about Pluto being a Kuiper object, and I think that because Pluto had so many fellow Kuiper objects out there eventually, that led to its demotion from being a planet to a dwarf planet. Anyway, that concludes our meeting for tonight, and so I'll bring the meeting to a close. Thank you all for coming, and I hope that this number of people in present will grow as the COVID goes away.
And thank Christy for the planetarium show.
Oh, yeah, Chrissy, yeah, good job. Yeah.
Monday morning, 11 o'clock.
Oh, yes, Monday morning, 11 o'clock. If you want to listen to our YouTube Astro Hour live, we're on from 11 to 12. We have it recorded, so you don't have to listen to it. For those of you that were up late all night observing these things, and so you can pick it up at any time. We generally have, from my read, about 3 to 5 people that watch it live, and then we pick up to 90 people later that watch it during the next week. So we have about, I think the last time I looked, we have 90 subscribers.
Is that right?
So it grows slightly every week.
More than I would have thought.
Is that what it is?
right.
Yeah, some weeks are good on the cartoons and some are not. Okay, thanks, everyone.
All right.